Greetings. Thank you for joining us today for EarthEcho STEMExplore Virtual Career Connection, featuring Dr. Carmen Boening, Deputy Section Manager at Jet Propulsion Laboratory, or JPL, in Pasadena, California. My name is Casey. I am a Programs Manager here at EarthEcho International, and we are so excited to have students from all over the globe joining us as we learn about exciting and sustainable careers in science, technology, engineering, and math. This live program is part of STEMExplore, EarthEcho's program that brings inspiration to life by telling stories of dynamic female professionals in STEM careers during live virtual career connections. We want to thank our founding sponsor, United Technologies, for their support of women in STEM as well as these programs. Here at EarthEcho, we believe that youth have the power to change the planet. Visit www.earthecho.org to learn more about our programs. You can also access resources like STEMExplore's career profile videos, as well as tune in for upcoming live events, just like this one. I'd like to recognize and thank STEMExplore's after-school partner sites across the country, and I really want to say hello to those that are joining us today. Now, we're going to head to California, to Santa Clarita, and we're going to visit the Boys and Girls Club of Santa Clarita Valley. So first, let's head over to the Newhall Clubhouse. Hello, Newhall. How is everyone? Great to see you. All right, let's head across town to the Sierra Vista Clubhouse. Hello, Sierra Vista.
Hi.
Hi, so wonderful to see everyone. We're so excited that you can join us. And also, I'd like to give a warm welcome to everyone watching on our live streams. And this is just a reminder that you can send in questions throughout tonight's program. You can send those questions for a STEM expert via chat, and we will break throughout today's presentation to see if you do have any questions for her. So feel free to start typing questions in the chat space on YouTube or in this live Zoom feed. We'll be sure to answer those as we go along. Now, let's get started. I want to welcome our special guest for EarthEcho's STEMExplore Virtual Career Connection, Dr. Carmen Boening. Hello, Carmen. How are you?
Hello. I'm good.
Good. Wonderful to see you. Thank you so much for joining us.
Yeah, thank you so much for having me, and thanks for everyone for spending the time with me here tonight and see where I work and how I grew up. It's very special to me, and I think EarthEcho is a great program, great organization, and I'm so honored to be on this program.
All right. Well, we're so excited to have you. Now, for those of you tuning in, Dr. Carmen Boening is a research scientist and deputy manager of the Earth Science section at NASA's Jet Propulsion Laboratory, or JPL, California Institute of Technology. She has received her PhD in physics with a focus on physical oceanography in 2009 from the University of Bremen, Germany. Dr. Boening joined JPL in the same year as a postdoc to work primarily on investigating global ocean circulation as measured by GRACE, or the Gravity Recovery and Climate Experiment. She was appointed as GRACE's project scientist and group supervisor at JPL's Sea Level and Ice Group in 2015. In early 2018, she joined the JPL Earth Science Section Management Team as deputy manager. Her research interests are in interdisciplinary sea level science and climate and ocean interactions, utilizing data from various satellite missions and climate models. Mm-hmm. All right, Dr. Boening, let's dive right in. Why don't you tell us a little bit more about where you work and what you do?
Very good. Thank you. And as you've already heard, we love our acronyms, and I will try to explain each one of them as they come up. So let me explain where we are. JPL is located in Pasadena, California. That's very close to Los Angeles, as you guys in Santa Clarita will know. And so I wanted to tell you a little bit about the story of JPL and why we're called JPL. And for that, I found a nice website that is on our JPL space, and it explains a little bit about what JPL was and what it is now. So we're called the Jet Propulsion Lab, and how it all got started was with grad students at Caltech that came up to the space that is now JPL that you see on the left there. And so you can see how it looked then and how it looks now. You could check out the page. This is kind of interesting. So it was called, so these students went up there to test their rockets. So they built little rockets, that was the newest thing. So it was just a bunch of students having some fun in the mountains. And then actually at some point with the space race going on, at that time, JPL was tasked to try to send the first science satellite into space, which we successfully did in 1958. That was the so-called Explorer mission. And that was the first satellite that had a scientific measurement on board, and it measured the Earth radiation belts. So starting from there with that success, the country then decided it wanted to have not only it wanted to have a public space program. So with that, NASA got funded, and JPL became part of NASA through Caltech. We're still managed by Caltech, actually. We're not what they now call the NASA centers, like you might have heard of the Kennedy Space Center. We're not technically a center, we're a contractor to NASA through Caltech, so we still have that connection there. And so now JPL, as you can see, has grown a lot, and we do a lot of different things now. So now maybe let's go back to the slides. I can tell you a little bit about what we've done from then to now, and that we're actually not doing much of the jet propulsion anymore. We're actually building more satellites. And so let's look at that. So yeah, I mentioned we built the first satellite, and with that NASA got started. From then to now, we actually explored all of our solar system's planets, from Mercury to Neptune, and we actually visited Pluto too, even though it's now not a planet anymore. And we built and operated all of the Mars rovers, and that is really something that JPL is very well known for. We're a planetary lab, but we also do Earth science, and we've made a lot of progress in measuring our planets. So this is basically what my work is in. So Earth science at JPL, and looking at our home planet. And so to guide our research, we have specific quests that we're set out to solve, and we have different themes, but we want to understand basically how the Earth works as a system. We have realized everything is connected, and so we have different themes that we're looking at, like water availability, sea level rise, natural hazards, carbon, ecosystems, weather, and air quality. So these are our themes. We do the science exploration, and then we hand off the data to some of these agencies like NOAA and so on to develop applications from these data. All of our data is freely available, so they can work with the data and then make smart decisions based on these data. So on the next slide, we see how our flow works. We're working more on the science discovery side, and then we're developing some of the applications, which means something for water resource measurement, water resource management, or weather forecasting, improving the weather forecasting. But then at some point we hand those off to the other agencies. And so we do this in many different ways. So we have many satellites that fly around Earth and look at all the different components of the Earth system. We look at the oceans, the atmosphere, the ice sheets, the land hydrology, which means the rivers and lakes and groundwaters. But we also work on airborne missions. We do airborne surveys that fly and measure locally. And then we also have in situ observations. What that means, those are instruments that measure things at a singular point. You see like these little helicopters there, or like some drones that measure something. And so what that does, it helps us to connect the local to the regional information to the global information. So then yeah, so this is just to show you how many NASA satellites actually fly around Earth at this point. And it's about 20 NASA satellites that are not just NASA, but we actually work with a lot with the International Space Agency. So a lot of these have international partners. One of them is Germany.
That is such a cool animation to bring that to life.
Yeah, it's fun. Actually, there's some apps too that I could, like send at some point.
Yeah. Now, just by show of hands, I'm curious, at Boys and Girls Club, how many of you have ever looked up at the night sky and seen a satellite? Mm-hmm. All right, a few of you at Sierra Vista. Excellent. A couple of you at Newhall. So I encourage you, if you have a clear night sky over this long holiday weekend, look up and see if you can spot a satellite. And there are some really cool apps too that you can stargaze with and try and find those satellites. It's pretty neat. Yeah.
And so now I wanted to say a little bit about what I do there. And so I'm a scientist there, and we have different science roles at JPL. We're all grouped into one science division made up of about like 300 scientists and in different fields. So earth science being one of them, and then we have planetary and astrophysics. So I'm in the earth science section of the science division. And so what roles do scientists have? We have the research scientists who work on the publications, who analyze the data, the project enabling scientists. So when we have a satellite mission, there is a project formed around that. So a project means just the group of people who work on implementing and then launching at some point the mission. So project enabling scientists, the technologists and instrumentalists that are actually working on developing the instruments that go onto the spacecraft that goes into space. Then for these projects, we need to have project science leadership. I have a role in that, which I will talk about in a little bit. And then programmatic scientists and science management, which I also do. And so some things that we do in general, and this is not only limited to JPL, but maybe as for scientists as a whole, we work a lot in laboratories or observatories or other hands-on locations, programming, coding, running simulations, and analyzing data. That's a lot of our job. So people always ask me when they come to JPL to interview scientists, like, can you show me your day-to-day work and let's see something very exciting. It's like, well, most of the time I spend behind my screen, like analyzing data. So that might not be exciting, but visualizing it, looking at the data that comes from space, I think that's a really cool thing. So, and then at some point you find something interesting, you write a journal article or reports that get reviewed by other scientists that check if you're doing things right. And then it gets published in journals, in scientific journals. And so then you come up with a new idea, you actually develop and write proposals for fundings to get more, like science ideas developed. And spending time doing long-term thinking, we do that a little bit if time allows. So just to see where Earth science is headed, what should we do next? What haven't we observed yet? What haven't we learned about Earth yet? And what can we do? At JPL, we actually put a lot of emphasis on teamwork. We all work in big teams, which is a little bit different sometimes from university scientists. University scientists often maybe work on their own project, usually in one office working with their professor, but we get to work in bigger teams. And actually what's nice about JPL is also that it spreads a lot across the different disciplines, which I will show in a bit. And so while, while most of the time it's analyzing data, sitting at the computer, maybe in team meetings, project meetings, but sometimes we get fun things, we have fun things to do. So sometimes we meet the NASA administrator, which we met recently for a project called Grace Follow-On. Casey described GRACE, or described the acronym GRACE. So now there's another mission that got launched recently to connect the time series that GRACE had to the next part of the decade, GRACE Follow-On. So he came by, visited, and then we get to actually see where the satellites are built. So this is a visit that I did in Germany, and actually checking out the satellites there. So I work on the GRACE mission as the GRACE mission's project scientist. So what does the project scientist do? I'm trying to make sure that all the science goals that the mission has are met through all the phases, and I'm going to explain what that means in a bit. But I'm also the person at JPL responsible to represent JPL interests in all matters related to the science, which is then the data processing and delivery. While we get the data from the satellite, it comes as bits, as ones and zeros, and at some point you got to make a map of Earth. So a lot of people are working on that and transforming these bits into the maps. And so I'm the person who makes sure that that gets done in the right way. And yeah, so this is basically just to show you, this looks complicated, but it's just to show you that, it's one thing to come up with an idea for a mission, like we should measure that, well, we have this instrument and do this. But it actually takes a lot of time to put all the pieces together. So NASA developed this system where we work in phases, where we develop the concept step by step. And at each step, when each step is finished, we stop, we have a review and see that everything is still on track and everything is working out. So now the mission that I'm working on, the GRACE mission, you see the satellites here. These look like two big boxes, which they basically are. So they're a little bit different from conventional satellites in the sense that they're not scanning anything on Earth. They're actually just tracking each other. So why is that important, and why do we do that? So what we want to measure is how water is moving around the Earth. And one of these components is, for example, groundwater. So we want to know like how much groundwater people are using, if we should watch out in a drought, how much water we're using. But it's really hard to do that from space, because if you just look at the surface, you might not see what's happening underneath. So, but we do know that water has a weight. So water is heavy. So if water is heavy and if it has a weight, and if you take some of that weight away, you take some water away, you actually change the gravity field. So these changes happen, like these are very small changes. So now we actually measure that with these two satellites, which you see at the bottom there on the right. These are satellites that track each other and track their position. So basically what we measure is not anything scanning, but we actually measure the pull of the gravity on the satellites. And by very accurately looking at where the satellites are, and then seeing how much gravity pulls on different places of the Earth over time, we can actually see how water is changing on Earth. And so in the next video that you're gonna see, we see an example of that. So here you see the Greenland ice sheet. So the colors actually show you where Greenland lost ice mass. And you can see it turning from white to more red. And these blobs actually indicate glacier systems. So these are the places where water gets where ice melts and then the water flows into the ocean from the land. So the ice sheet is less heavy at that point, and we can measure that with the gray satellite. And then for Antarctica, we see the same thing. In certain areas, it's melting a lot. We understand from the science why this is happening. For Greenland, it's more because the atmosphere is getting warmer. For Antarctica, it's more because the ocean is warming the ice shelves from underneath and pull out the ice more, because the ice is thinning and melting. So the ice in the interior gets pushed out. So that's the dark blob that you see there. So, and then I wanted to show you one of the science examples that I worked on. Just a quick, like what does it look like when you summarize the science result? So one of my articles, which I personally liked, because, and I explain why. So that got published in 2012. So I wrote with a team of scientists. I wrote a publication there. And so this is then just to explain quickly on the slide, like which these slides get sent to NASA to see, like what are their scientists doing. And so I thought this paper, this project was pretty neat, because it showed in a way how the different components of the Earth are connected. So the result from this paper was that there was, during 2010, 2011, there was such a big fluctuation in the atmosphere that caused a lot of evaporation from the ocean. So there was a lot of water mass pulled out of the ocean, and then the winds transported that to Australia and northern South America, and actually caused some floods there. And so how we looked at that was, well, we saw this drop in the global mean sea level. And so one of the reasons why it could drop was either it would get colder, so the water would contract, or there would be less water in the ocean. And so now with the gray satellites, we were able to weigh the oceans and see, yeah, there was less water. And then also with grays, we were able to weigh the continents and see where the water went. So basically a drop in ocean sea level caused a flood in Australia. So I thought that was neat and got me thinking of Earth as a system.
That is incredible. Wow.
Thank you. Yeah, so, and then also in addition to the project work, I also work in so-called line management, so that we're organized in different divisions. I explained the science division. And so I work in the Earth Science section as the deputy manager. We're a team of 3 people. Sue Owen and Victor Slotnicki work with me as the management team. We have about 140 scientists working in that section, and we're working with the directorates to provide the strategic vision, like what should Earth science be at JPL, at NASA. And then we do, like the down on the ground work on the data analysis and implementing the science goals, work on missions and so on. And here you can see like the different groups we're organized in. So we have different themes, or a lot of atmospheric science. We look at rivers and lakes and groundwater in the terrestrial hydrology. We look at ocean circulation. We look at the Earth's surface and interior, like volcanoes or earthquakes, or the carbon cycle, like how much CO2 is there in the atmosphere and how does it impact the ecosystem, and so on and so forth. So it's a big section, and what I was describing about that we're lucky that we have, like our big teams at JPL, this is kind of signifies it. You have all these different disciplines, so you can just walk over and knock on someone's door who is an expert in a completely different discipline, and you can collaborate and really make some progress on this Earth system science.
Wow.
Okay, and these are our strategic themes. So we look at the different cycles. We look at the water cycle, how sea level is changing, which I explained has to do not only with the ocean, but also with the ice sheets. The ice sheets losing mass, that mass goes into the ocean, and so on. And the carbon cycle, ecosystems, and improving weather models. So we try to come up with new satellites, new instruments that can improve our weather models. And then look at what are, what makes a volcano go off, or what causes an earthquake, and so on. And these are basically all the different Earth science projects or Earth science missions that we're currently involved in. So it's a big spread. It can get sometimes overwhelming to put all the pieces together.
That is a lot of work. Well,
Yes.
Thank you. That was a wonderful in-depth overview of what you do and who JPL is and what they do. This is all really fascinating and fantastic. So I think it's a great time to break for questions. So we are going to take questions from the chat space. So if you are viewing our live streams, be sure to type those questions into the chat space and we'll be able to ask Dr. Carmen of those. But let's go to our interactive sites that we have online in Santa Clarita, California. Let's head over to the Boys and Girls Club of Santa Clarita Valley. Let's start with the Sierra Vista Club. What questions do you have for Dr. Carmen, Sierra Vista?
So we have a question right here.
So how often do you study about earthquakes?
Ooh, how often do you study about earthquakes? And if you don't directly study earthquakes, do you know somebody who does?
I do. I actually do. I mean, we have a group dedicated to this topics, and I think they look at all. I definitely the big earthquakes. I think that starts for them at a scale of 5. If you heard about the Richter scale. And they studied those. And so for LA, we have a lot of the small earthquakes that you might not even feel. So we look at those too. And then for the big ones, we actually see some of these signals in our gravity data too. So I don't know if you can see my hands, earthquakes either happen like this, the plates move like that, and that shakes up the earth, or they move on top of each other. There's so much pressure that they go on top of each other. And so once that happens, you all of a sudden you have a whole bunch of basically mass there, and we can see that in the gravity data because the mass of the earth changed at that point. And so with that, we can actually, when that happens in the ocean, it disturbs the ocean, and then a tsunami gets created, and we can see that also in the data.
Incredible. All right, Sierra Vista, do you have another question?
Thank you. Let's see. Do we have any other questions?
Not yet.
Yeah, that's it for right now. Thank you.
Okay, sounds good. We will definitely come back. If you think of any, also write them down, and that way you can remember them as well. All right, let's head across town to the Newhall Clubhouse. Newhall, what questions do you have for Dr. Carmen? There you go. You're good.
Oh, sorry. I'm so glad.
Oh, can you hear us?
Yeah, we can hear you.
So I guess I'll be asking the first question.
Perfect.
Since you guys are basically studying on environmental factors that are affecting the global temperature and environment, do you think there would be any possible way to reduce or possibly counter the effects of global warming?
Wow, excellent question.
So the overall question Yes, great question. If we can account for the effects of global warming, right?
Yeah, and if we could possibly have an effect to kind of reverse what's happening.
Right, right. I will actually talk about that in a different in the context of a different project later. So what we do at NASA is mainly studying, you know, like what's happening, what's going on, and being able to quantify, you know, like how much of carbon dioxide there is in the atmosphere, and then how that is related to the temperature. So what NASA is trying to do is provide that information to any of the people and institutions to come up with solutions. What that also gives you is basically it points out, you know, the different sources of, you know, like the greenhouse gases. And so because we make global measurements, and it's then very easy to see where the sources are, and people then are able to take action if they see something's there. You know, there's companies that produce too much CO2, they can actually do something about that. And there is actually a lot of interest in finding these things with the data. It has been of a lot of interest also to well, the people who have, you know, like oil in the oil industry, if they have leaks, they want to know where they are so that they can stop them. And so the data is helping with that. Overall, NASA tries to be neutral and provide the data, but we talk to people. It's like, hey, how, like, if you want to make progress, what is the best data type that you could wish for, and then would try to make it happen. So in that way, we're trying to stay active and actually talk a lot with the people who are using the data to try to make a difference.
Great. All right, Newhall Clubhouse, do you have another question?
No.
Not right now? Okay, that was a good one. We do have a question coming in from the chat, and our viewer wants to know, do you have a lot of female colleagues at JPL?
I actually do. Yes, yeah. I mean, I do. My colleague, Sue Owen, who is actually my manager, we work in the management team for the section, and we have a lot of scientists in our groups who are female, and so it's, I think we're getting more and more. I still, you know, when I first started at JPL, I always find myself thinking after like half an hour in the meeting, I look around, it's like, hey, I'm the only woman here. So it's still, especially in the engineering meetings that I'm in, it can happen a lot still that I'm the only woman there. And but I feel like, I mean, there's really no reason why there shouldn't be more women. And I encourage all the girls, you know, like if that's your passion, you should really go for it. And yeah, I think it's very important.
I agree. All right. Well, those were great questions. We will come back for another round of questions in just a few minutes. But before we get to that, Carmen, why don't we kind of back up your story a little bit? And why don't you tell us a little bit more about where you grew up and kind of how you got into your career?
Yes, perfect. And I feel like I'm getting dark here. Should I turn on the light a little bit?
You could if you want to. If you want to keep talking and turn on a light, that is perfectly fine.
Very good. Yes, let me make a little bit more light here from the, this is a little bit better. So where I grew up. So as you've heard, I came from Germany, and I grew up in a little town that is called Westrauderveen. It's in Ostfriesland, East Frisia, in the northwest of Germany. And to me, it's a very special region. So it was the first proven historical event was 12 before Christ, when the Romans came to that region, and they they went down the river and then just went back, I think because they thought like, oh, there's nothing to do here. It was kind of a swamp there. So it was very hard to settle there. But at some point, there were some tribes that are settling there. And so that's when they started digging these canals into the moors to drain the water and make it livable. So this is what you see on the left. That's actually the street where I grew up. Like right there on the left, that's my parents' house. You don't see it, but that's the canal I grew up on. And so, and it is kind of like it has originated as a fairly independent part of the country. The Romans and others have tried to conquer it several times and have never succeeded. So it was always a special place. So that's where it's located. And so then, yeah, growing up, I was always very, nature was very, very important to me. I liked to be outdoors. I couldn't wait after school, after I got my homework done, to just go outside and climb trees. Even then, I had a little cat, so we would both climb on the trees. And I like to build things. As you can see, I like to build like sand castles, but also with my friends, bow and arrows, we would go out. So I liked engineering and exploring things. I like to discover things. And so that's then my mom actually had a passion for swimming and also ice skating. So my mom was always like, she would take us kids whatever she would want to do. So she wanted to go swimming. She took us there, me and my two brothers. And so that's how I got into swimming. Like after school, I would go to a swim club and I would do competitive swimming. And I think that was very important to me, because it's then you're part of a team. And so really this, like the team activities then were a big part of that. And I think that really also helps me now in my job. So to work in teams is a big part of the job too. And oh yeah, and maybe if you want to go back, I thought the picture on the right was funny, like now everybody's complaining that nobody talks to anybody anymore and everybody's looking at their screens, but like back then it already happened. People managed to not talk to each other even without the tablets.
That's funny.
Yeah.
I love that.
And ice skating, as you can imagine, these long canals lend themselves to ice skating. So that was our big passion. And I said, while we're sometimes pushing the limits of the laws of physics, we were always the first people on the ice. And it was actually my elementary school teacher who would go out, he would test the ice and he would call us. And then my mom and my family, we would go out on the ice. And that was a wonderful time. So, but that was always a little bit on the edge. The ice would crack a lot. So we're pushing the laws of physics here.
Absolutely.
And I found this one in preparation for this. My friend, when I turned 25, my friend Marion, she prepared this little book of little memories. And I thought it was cute also because it documents that she also already realized at that time that I was very interested in science, engineering, and actually also music. As an outside activity, I learned how to play the piano. I was actually in high school. My high school had a program where you could take music as a major. I joined the school choir. So music and math, that was a big part of my life and a big part of my passion already then. And in many ways, I think those two are related, because with music, you work with different frequencies, and with math and physics, you kind of do the same. So it's very similar.
Absolutely. I think we should never underestimate music and the skills that you gain and the power of music. So it's good.
And then I was fascinated by some of the TV shows that we had. So we only had 3 channels at the time when I grew up, and 3 German channels and 2 Dutch channels. So on these German channels, I used to watch a show called Quarks and Co. And so they explained things about the universe. I was very interested in astrophysics and astronomy. And then I think this one is funny because it's called the Knopfhoff show. So it's the know-how show, but it's pronounced in German. So they did little physics experiments and chemistry, and I was just fascinated by that. And then on Dutch television, they had Star Trek Next Generation. And even though it was English television or American television with Dutch subtitles, I kept watching it. I probably wouldn't understand a word, but I was fascinated. So I just loved that. And then Casey, we talked about the Erich von Däniken. There is a TV show that my dad and I used to watch, and that was, you know, looking at signatures that he thought might be signs of aliens on Earth. So we would watch that, and I was just fascinated by that. So that was kind of like what shaped me, that I wanted to go explore, I wanted to do science. And so, yeah, even though I had all these things that inspired me, I think my biggest inspiration were always my family and my friends. And also my biggest supporters. I was lucky, my parents would always let me do whatever I wanted to do. I wanted to do swimming. It's like, okay, you go swimming. I wanted to learn the piano. You go learn the piano. The only time they said no was with tennis. I really wanted to do tennis because a friend of mine was doing that, and they said no, because they said, actually, you're doing enough with swimming and the piano lessons, so no tennis for you. So now I took up tennis at 35, so I'm doing it now. So
never too late.
Never too late. Yeah, but it really, I was so lucky that they let me do that, but they also, you know, like they said, well, this is enough. You still need time to play. You need time with your friends. So don't do too much. And I really appreciate it. I think that helped me a lot in my growth. And so from there, I moved to Bremen in Germany, which wasn't that far away. I always actually wanted to go somewhere like very, very far. Then I ended up in Bremen, which is like 1.5 hours from my parents. So here I am, still very close, which was convenient for laundry and stuff, but and it was a nice experience. So my parents actually wanted to, for me to have a solid job first before I go to university. So I joined a company after high school. And in Germany, we have these apprenticeships where you can work for a few years with the company, and they let you work in different sections of the company. And at the same time, you take classes too. So I took classes in software engineering and development, computer science, mathematics. And for them, I was doing software engineering and development. And I like that picture of the company. It actually looked like that. It's one of their simulators. I think it's a simulator of a nuclear power plant. It kind of looked like an old episode of Star Trek there. So
it does. It does.
I kind of like that. So, and then I finished that. I had a real job, and so I was allowed to go to the university. I studied mathematics and computer science, mathematics as my major and computer science as a minor. And from then, like what I do, I started thinking like what's next. Mathematics was always a little bit theoretical. I wanted to do something more practical. But then a lot of my friends would go to a bank or insurance company, and that wasn't really mine. So I was lucky to find a position at a Marine and Polar Research Institute. When they described the position to me, actually they were interviewing at that time for 3 grad students positions, and they described the positions. And at that point, like the last time I did physics was in high school, and I wasn't understanding like too much of the technical detail that they were mentioning. In the end, they said like, oh yeah, which one do you think is the most interesting? And I said, well, the third one sounds very interesting. And so the third one was my lucky pick, because it was then working with the GRACE mission. The GRACE mission is a joint project between Germany and the US. So I started working on that. I finished my PhD on that. And then JPL had a postdoc position open, directly relating to what I was working on my thesis. So I became a postdoc, and then I think we heard a little bit about what I've done since then. I got hired at JPL in 2011, and then became the project scientist of the mission in 2015, which I feel very grateful for, because as a PhD, starting on the mission and then becoming the project scientist is very, very special. And then group supervisor, and now in section management.
Awesome. Great. So here at EarthEcho International, we believe that we can act now for a sustainable future. So can you speak a little bit to, and a lot of this is kind of obvious, but the work that you're doing, how does that contribute to a sustainable future?
Yes. So that relates to the question that was asked before. So at NASA, we were only allowed to stay on the more passive sense that we are open to what we should measure. Of course, people should tell us what we should do, but then we provide the data. It's all free, freely available, and so that helps to monitor and understand our impact on the planet. And so our data, I think, is unique in a sense that it provides us a view of the global system, and not only, I mean, we can say, I look outside, I look, it's raining today, or it's snowing or something, and then you could think like, oh well, global warming isn't happening. But actually, because we have the satellites, we can measure the global temperature, and we can clearly see that it's warming. And so we can make the distinction between what is happening locally versus what is happening globally. And I think that is a great perspective to have, and to continue to have, to be able to plan for changing things. And then hopefully, I think, with all the changes that people are making right now, we're hopefully the witness then also of the positive changes that we'll make.
Absolutely.
And then I just wanted to mention the two organizations that I recently became interested in, because in addition to my science, I also want to do something. And I found the Pachamama Alliance, which helps people to learn about, not only climate change, but also, like how to live a sustainable future, work with people, and they're very engaged in that. And then one particular project is the Project Drawdown. And so I think that is interesting, because I talked to a friend of mine, and he asked, has anybody ever calculated what it would take to reduce the carbon down to a sustainable level? And I said, well, I don't know any scientists that have done that. And then a few days later, I found this book. And so this book describes concrete solutions, like what should we do, and how much carbon dioxide can we take from the atmosphere and put it back to places where it's sustainably held. And I think that that's a great calculation that somebody has done, and they identify 200 different solutions. Wow. And rank them, and by how much carbon dioxide these different things can take out of the atmosphere. Just like things like planting trees is one of them, or using energy from windmills or other things. And
that's great. What a great resource. I'm going to have to check that out.
Yes, yeah.
Great. All right, everyone. So we are now to our last slate of questions before we wrap things up. So let's head to our friends at the Boys and Girls Club of Santa Clarita Valley. Why don't we go ahead and start with the Newhall Clubhouse this time? Newhall, what questions do you have for Dr. Carmen?
It's me again. Okay.
All right.
Oh, like how many years in total have you been working at NASA? And like, do you enjoy your job? Is it difficult, or like, is it something you'd recommend for other people that are pursuing their field in the work of, science and everything?
Great question.
Okay, yeah, I've been at JPL now 10 years total. So that's a good long time. So which also means that I'm enjoying it there. So it's a good environment. I think it's like when you think about a science career and going to a university versus a research lab, there are certain things that people should think about. Like for a university, you're more on your own. You gotta make your collaborations. It can be difficult. What I like about JPL and doing research there is that you have all the expertise in the different areas there. And even if I think, well, Mars has an atmosphere and we have people who are scientists studying the Mars atmosphere. If I want to see if that's connected to our Earth atmosphere, I can just walk over to the other building and talk to these people. I think what's also exciting is, well, working on actual missions, like missions, like satellite missions that are gonna be in space, gonna be up there and measuring stuff. So that's very unique that just not a lot of people get to do.
Great. Newhall Clubhouse, do you have another question?
I have a question. How many years did it take for you to get into NASA?
How many years did it take for her to get into NASA and JPL? Great question.
Yeah, that's a great question. So let's see if we can do the count. Well, if we count the apprenticeship, then that was 3 years. If we count the time at university, so my master's, or what we call diploma, was 4.5 years, and then my PhD was 3.5. So that part was 8 years to get to my PhD. And then with the PhD, I was able to apply for a postdoc, what they call a postdoc position, which is a contract for 1 or 2 year working as a researcher there. And then after that, I applied for the permanent position, and that's when I got hired. So it can take a while. Yeah. You gotta be passionate about that.
Awesome. Great questions, Newhall Clubhouse. Let's go across town to Sierra Vista. We're running a little bit late, so if you do have other questions, of course, Boys and Girls Club, you can always email those to me or email Carmen directly. We'll have that up in just a second. But let's head across town to the Sierra Vista Clubhouse to see if we can answer any questions from there.
One of the girls just had a question about how many years in total was schooling, but I feel like I know you kind of touched on it though, but.
Yeah, so I would say the school part was about 8 years at university. Yeah.
Okay. And we also have a question in regards to NASA, when the most recent launch you had was.
That is a good question.
That's a really good question. I can try and Google that.
Yeah. we had several recent launches. I think the OCO3 mission was the recent launch, which was an instrument that went to the International Space Station and is now installed on the International Space Station, measuring carbon dioxide from that.
Oh,
And
wow.
then just recently before that, we had the so-called EcoStress mission, and that's also on the ISS. And EcoStress looks at the thermal signatures of Earth, and they basically look at like how much are plants stressed out. You can actually see that through the infrared measurements that we get from that, and see, you know, like that informs farmers if they need to maybe water their plants more and so on, or which are good. Yeah.
Great. Awesome questions, you guys. And again, if you have more questions, you can send those my way or to Carmen's way. You'll see her email in just a second. So Carmen, one question coming in from the chat that I have to ask you. Who is your favorite Star Trek character?
Nice. I personally, I have two favorites. I think my first is Commander Data, and second, close up there, is Captain Picard.
Perfect. And just so any last words of wisdom or any advice that you would give to students out there?
Yes, I thought about that question, and I really think, you know, like with all the freedom that I had in my childhood, I think that really helped me. So the advice I want to give is that it is important to listen to your heart when it comes to what you want to do. Find inspiration in what you do and the people that you meet. And I mean, no matter what anyone else says, it's your decision after all, and you gotta see what's right for you. And it can be in science, or it can be, I don't know, it can be anything, you know, like it just matters what is important to you. And stay curious, ask questions. Don't let anybody say that you can't any questions. So don't feel shy to ask questions or ask for help. There's never a stupid question. And we're really all in this together as the Earth, as humanity, and we need each other to succeed. And I think when it comes to climate and the Earth and sustainability, so there's a lot to do. And I think we together we can do it. We can create a great future for everyone.
I agree. Great words of advice from Dr. Boening. And I want to thank you again, Carmen, for joining us today for this STEMExplore Virtual Career Connection. Everyone out there, you can stay tuned and follow Carmen on social media. She was nice enough to give us her email addresses to share. So if anybody has any follow-up questions, you can definitely send those to her. Boys and Girls Club students, of course, you can send those my way as well. And of course, you can follow all the cool things that NASA and JPL are doing, as well as the California Institute of Technology right there on their website. So thank you, Dr. Boening, for joining us. This was wonderful, and what a fascinating career and fascinating life you've led. We can't wait to see what happens next.
Yeah, thank you so much for having me.
Absolutely. And of course, I want to thank all of our STEMExplore after school partners, especially the Boys and Girls Club of Santa Clarita Valley who tuned in today, Newhall Clubhouse, and Sierra Vista. Thank you so much. It was great to have you. And thanks to everyone who tuned into our live streams. And just a reminder that EarthEcho has some exciting things coming up. We will continue with STEMExplore Virtual Career Connections, connecting with women in STEM careers, all throughout the month of December. So be sure to visit our website, check out that lineup, and register for these programs. If you register, you'll be able to chat live with our featured expert that we have. And we have many more to come next month. And so stay tuned again to that website, and stay tuned, of course, to all of our social media channels and follow us. You can get the latest news and updates there. Of course, there's our website again, earthecho.org. That's where you can find all of our program information as well as our resources. Again, one last big thank you to our wonderful STEMExplore mentor, Dr. Carmen Boening, and to United Technologies for their tremendous support of this program. So on behalf of EarthEcho International, thank you all for joining us, and keep exploring. Bye-bye, everyone.
Bye, thank you.